Hello everyone and welcome to this new YouTube tutorial where we are going to be talking about this dragon shot that I built this past week. And as always, this project is fully available on my Gumroad page, so if you want to have access to the whole setup, you can download it in there. In this tutorial we are going to be focusing into the fire layers, into the effects of those fire layers, and I'm not going to be covering the layout, cameras. I'm not going to be talking about the environment because otherwise the tutorial will be really long. I'm not going to be covering the clouds, how I made the clouds. All those things are available on the actual file, and I'm not going to be covering the shading, the lighting and the rendering because otherwise the tutorial will be really long, as I had to do some custom tweaks on the shaders and all those things. So we are going to focus only on the main fire layers and all those cool effects. So starting with the main fire layer, which is the dragon breath, the good thing about this shot is that I have a static head, a static dragon, so I only needed to place a basic sphere and just give it some random noises to break a little bit the shape and use a point velocity node to have some curl noise and some conical noise into the main velocities of the particles. And we just scatter some points in there as our emitter, and we go into our first simulation, which is a flip sim. And yeah, I said a flip sim because for some reason I wanted to explore the possibility of using a flip simulation instead of a particle simulation, just to try to have that clumpiness feeling into the particles similar to what a fluid will behave. And after using this method, I could say that probably you could go with a particle simulation instead of using a flip sim. You could do a lot of tweaks in the pop sim and after the sim, so you could have a really good emitter for your fire. You don't need to use a flip simulation, which is going to be always a little bit slower than a particle sim. But just for you to know, yes, I'm using a flip sim. And inside the flip sim I don't have anything really special, just a pop drag, a pop force, a collider group, which is a group where I'm introducing all the particles that are near the actual floor, which needs to be set as an input of this wrangle. But yeah, just because I wanted to do some tweaking of those particles after the sim, but that's pretty much it. You just need to create your flip solver with making sure that you have an ID attribute and you have your edge particles and rip particles enabled, and that's pretty much it. You need to make sure that you have your environment as a collider, and you will have this very basic sim that, as you are going to see after this, we are going to start tweaking post simulation to have exactly what we want for our emitter. The first thing that I'm doing post simulation is taking my collider group, which are the points colliding with the floor, and raying them into the floor, just because I wanted to make sure that all those points stays on the floor for the whole time. Then I'm just blurring the position of the points to create a little bit more of that clumpy feeling in the particles. Finally, I'm using a near points function to isolate the sparse points and delete them. This function basically creates an array of points that I can use to compare it to a threshold and say something like, hey, if the length of this array is less than a certain threshold, that means that my current point didn't find a lot of points near him, so it's an isolated point, and this point should be deleted. I'm also adding some noise into the first part of the simulation just to break a little bit the linear shape of those particles, and finally I'm just replicating the points based on an attribute. In this case is the H attribute, so I get more points when the point H is a little bit higher and less points when the point just spawned. And once we have all those tweaks done, we just need to create the attributes to rasterize, which in this case are burn, temperature and divergence, and rasterize those points. We also need to make sure that we have a velocity attribute with a little bit of curl noise, which could be something as easy as using a point velocity node and giving them some cool noise in order to help the fire sim to have some breakups in those velocities. For the main fire simulation, the first thing that I'm doing is creating a box that represents the maximum domains of my pyrosim, just to make sure that if something goes out of that area, it won't be simulated, so I don't waste more resources of the ones that I need. And the only thing that you need to do is link the boundaries of this box into the smoke object. Then, as always, I make sure that I have my floor as a collider and my regular pyrosolver and volume source node, which is basically the node that I use to input the volumes I created before, which are the burn, temperature, and velocity. I also have all the regular microsolvers, which I'm not going to explain in this video because I'm pretty sure that everyone knows how to use the turbulence, how to use the disturbance and the dissipation inside a volume simulation. But I also have some custom velocity field sourcing and the creation of custom fields inside the sim, and I thought it would be nice to explain these techniques. For the custom velocity field sourcing, I wanted to have a swirl force that makes the fire go up in a certain area. For doing that, you just need to place a box, scatter some points inside, draw a curve that represents that movement that you want to have in your sim, and create a tangent U attribute with a polyframe node, which basically is a vector pointing in the direction of the curve. Then you just need to transfer that attribute to your points, add some noise on top of it, and create a BDB from that point attribute. And basically you will be ready to use it inside your simulation. In the sim, you need to use a gas wrangle to sample that velocity field, which needs to be called in one of the inputs of the node, and do a linear interpolation between the current velocity field and the custom swirl velocity field based on an attribute, based on a bias. In this case, my bias is a combination between the X and Y position. So let's say that if my bias is 1, I will be using my custom velocity field, and if it's 0, I won't be using it at all. The creation of custom fields inside the simulation is interesting. You could use them to control the influence of your microsolvers, basically your turbulence or your disturbance or whatever. And that's what I'm doing in here. So to create a field, you use a gas match field where you specify the name of the new field that you want to create and a reference field. In this case, I'm using the flame field. Then you just need to use a gas field bob to tweak the new field. And basically I'm getting the X component, fitting it to the values I want the field to influence my sim or my microsolvers, which also influence my sim, and export the field again. And that's basically it. It's simple and useful. Now you can control your microsolvers with this new custom field. After we have our simulation cached with all the BDB fields we need for future steps, I wanted to tweak a bit some of the fields because I wanted to basically separate the initial flame close to the dragon mouth, which would be something like the typical blue flame, and the rest of the sim, which is going to be the typical orange flame. So for doing that, I use a basic distance function to do those changes, and I'm basically trying to measure the distance between my position and the near point of the dragon mouth and fit that distance in order to tweak my density field. And I'm also doing some tweaks on the flame field, but yeah, that's pretty much it what I'm doing post-simulation. And I'm doing this 2 times, but using different and almost opposite values. So now I have 2 different layers that I will be rendering as separate layers. One will be for the blue flame, and one will be for the general orange flame density and whatever. Also, and you don't necessarily need to do this, I am building my own custom scatter field. And for doing this, I'm taking the field I want to use as a base for my scatter field. In this case, I'm using the flame and the density fields. I smooth the fields and I give them the same name, as I will be merging them together. This field will be basically used in the pyrobake node as a source volume to create the scatter volume, and that way it will drive my shader when I'm rendering this super cool fire. For the fire that is coming from the floor as a consequence of the main fire, we need to find where it should be created. For doing that, we take the main fire, blast all the fields except for the flame field, scatter points in that field, and use an attribute from volume node to get the flame mask attribute from the flame. Then we only need to transfer that attribute to the floor geometry, and that will give us the areas to source or secondary fire. But of course, we need to run a solver to get a more realistic feeling, because the attribute that we are transferring is changing per frame, and we would like to have the feeling that if an area is burning, it will slowly decrease the intensity of that flame or that burn, but it won't disappear from frame to frame. So basically what we do is run a solver, and inside that solver we are going to get the maximum value of that attribute comparing the current frame with the previous frame, which is also going to have a decreasing factor for the attribute per frame. So we get that feeling of the flame slowly reducing its intensity, and that's going to give us a more realistic area to source. Now that we have an attribute representing the burning area, we are going to add some noise on top of it, just to have some breakups on something more interesting to source from. And we use the attribute to scatter points that, as always, and I'm pretty sure that you already know this, we are going to rasterize the typical attributes as we did on our main fire simulation, which are the burn, temperature, velocity, and all those things. And this will be the emitter for our sim. I'm not going to explain this volume simulation because it's 90% the same as the main one, with the only difference that I didn't need to create custom fields to drive my microsolvers in this case, so it's even more simpler. Just the typical microsolvers, the pyro solver, and blah blah blah. I'm pretty sure that you guys already know all this, so yeah. And that's pretty much it. Finally, again, we cache our simulation with the fields we need for the shading and the rendering part, and voila! This layer is done too. For the Embers layer, we are going to take our floor simulation, we blast all the fields except for the flame and the velocity field. We filter that flame field based on the Y position because I wanted to spawn points only on the bottom area, and we scatter points in that volume. Then we use an attribute from volume to give the points the same velocities as the velocity field of the floor simulation. The particle sim is very simple. We just need to use the points as the source, which already have a nice emission velocity, and we use a pop at vect by volume node to make them inherit the velocity coming from the floor simulation velocity field. And again, we have some cool particles following the fire sim. To give them the Embers look, I'm using the Spark Trail node, which already have a lot of cool functions in it. It's going to basically create the lines, the Embers lines, and I can control the color intensity, the alpha, the length of the Embers, so I don't have to build all those things by myself because, well, basically I'm very lazy. So yeah, if I have a tool that already does everything, I'm going to use it. And then we give the Embers some noises to break the shapes, and we randomize a bit their length using a carve node that use a custom attribute that we create based on the ID attribute, so we get random lengths per Ember. For the floor heat map, I'm going to refer you to my waterfall and river video, as this map could be understood as a wet map, but well, I guess that in this case it would be called something like burn map or fire map or whatever, I guess. And I explain how to create that in that shot or in that video. And also, as I'm trying to be a cool content creator, I need to redirect all my people and my traffic to other videos and do all those things I guess a content creator does. So yeah, I'm trying. I hope you enjoyed the video and learned something new. And again, this project is fully available on my Gunrad page in case you want to learn how I built the environment, the clouds, the secondary smokes, or how I did the shading, the lighting, and the rendering with Karma. See ya!